We will continue with this walnut segmentation. Now let us see the effects of this box size and lambda on the segmentation process. Now these are the defaults 5 and 10. So I have selected the region to be tagged, defining it as the object region, and when I press T, this is the region that is being tagged with this current setting. Now let me press reset R and let me change lambda. See, lambda can go from 1 and it can go up to as high as 50. So lambda 1, and now let us see the effect. Press T and then you can see that it has tagged much more region, lot more region. Press R again, reset. Let us change it to say 20 and let us see the effect. And you see that this is much more tighter compared to the last one. So reset. So what lambda does is it basically defines how tighter or how close to your original originally painted region your final tagging would be. So that the lambda is 50. Press T and this is much more tighter and it is much more smoother. Press reset again, R and 10 and D, tag. So reset again. Now let us change the box size. Now what the box size does is it basically uses that parameter number 5 or 10 or whatever you give in. It uses that parameter to decide the average gradient in that region. So when the box size is 5, it is taking basically 5 by 5 box to 10 by 10 box to generate the average gradient information. So box size 1 is basically 3 by 3. Box size 1 will be 3 by 3, and then you see the effect. Reset. Box size say 5 by 5, 11 by 11, and see the effect. So this box size parameter is used to generate the average gradient information in the region for every pixel to be used in the tagging process, in the segmentation process. So if I use 10 and then press T, say 20, oops, 20 and press T, and so on. Typically 5 does a good job, but sometimes you might have to fiddle with these parameters to get the required segmentation. Typically using these parameters, if you can detect the boundary, then you can segment the object. So in this video let's segment this this nut here, this region. So press T. Now you can also keep on updating. So press T. I would also like to go here. Press T, and now I can press escape. So by pressing escape, I'll remove these paintings here, or we can continue towards the next slice, use the same regions that we were painted, and then press T again, press T again, press T again, T, and now we have a problem here. We don't want to tag this region. Even in the previous one we had tagged this, so press reset, press reset. Even here we had some tag, press reset, press reset, press reset, press R, reset, and so on. So T to tag. I don't want it to tag here. Press reset. what we can do is we can then play with the histogram, play with the transfer function here. So let me just play with that and then press tag. Next slice, press tag. Next slice, press tag. Next slice, press tag. Tag, and so on. Now the problem is here, this tag, the region that we have painted is actually not what we want to tag, so you can just remove that. Now we can't remove it here because this region, which is this region in the histogram, is not painted, it is 0. So let's take the transfer function here and then remove that tag, and then we can put it back here. Tag, tag, and so on. We missed it here, so put a dot here and then press tag, and then you can remove the dot, and so on. So this is one way where you can go slice by slice and then press T to tag the slices. So let me press escape to remove these markings. Press escape and then press reset. And so on. So now we have reset all the tags, so all the tags are 0. Now pressing T every time for every slice becomes a bit boring, and now in order to fix that, what we have is we can copy the tags from the previous slice, and then we can successively apply the tag operations. So let us first tag this region here. Tag. We can now remove the painting by pressing escape. So I have removed the painting. I can now copy the tags, and I can go to the next slice either by using left or right arrow key, or using the slider, or just by using the wheel. So next slice, so this is the next slice, and these are the tagging information that I'll be using from the previous slice. So this is the previous slice, and this is what I'm going to use. Now this shrink parameter here, it controls how much of this original tagging information will be shrunk for the next slice. So it is, next slice is in this case the previous slice or the next slice. So it could be one slice above or one slice below. Now when I change the slice shrink, it can be 0, so it will take the slice as it is, say 10, so it will be shrunk a lot, like that, say 15, and even more, and so on. So we can use this information. We don't need to do any painting of the slices, or we don't need to keep the user painted information. We can just use the information from the previous slice, and then press T, next slice T, next slice T, next slice T, next slice T, and so on. And similarly we can go up the slice rather than going one slice below. You can go one slice above, and so on. Okay, let's reset that again. Next slice, reset, and so on. So all the slices have been reset. Now we can reduce our task even further. Now what we have done is we painted the region using marking the region using the tags, and then we pressed T to tag the region. Then we pressed escape to remove the user painted tags. Then we use the copy tags option here to copy the tags from the previous slice to the next one, whether it is the one above or below the slice, and then pressing T to tag the next slice. Now we can automate this whole process by let me show you how. So again, tag here, press T, and now press escape to remove this painted information. Now what I can do is I can restrict my tagging to a certain region. So this is the region in which I want to set my tags. Now what I can do is, this is my currently tagged region. This is the current slice which I have tagged. Increase that, and I can press Shift T, so capital T. Let me see what it does. Let me show you what it does. Capital T will basically apply the tagging operation recursively to the slices. So Shift T, so repeat the tagging operations over multiple slices, and then you can stop that by pressing escape. So let me just increase that slice. Now I am pressing Shift T or capital T, and this operation will be repeated over multiple slices. I am going to copy these tags to the next slice, shrink it by 5, this parameter 5, and then apply the tagging operation using this box size and this lambda over multiple slices. So Shift T, and you can apply the operation in forward direction, which is in this direction here down, or backward direction, which is going up here. So let's apply it in the forward direction. Okay, and this is going automatically. You can also press again Shift T, forward direction, and I'm not pressing any key, and this is being done automatically, and I can press escape when I want to stop this process. So these are the slices, that's the information that is being tagged. Let's continue with the operation. Again, Shift T forward, and let it go through all the slices here. And let us also continue down below, say up to this point. And again Shift T forward. Okay, and let's see how far we can go back. So up to this point here, maybe a bit below. Okay, and then we can start this tagging operation again from, say, this slice here. So again press Shift T, and now in this, right now we want to go backwards, so press backwards and OK, and you will have your data tagged. That's it, done. Now let us see how this looks. So this is what, let me just turn off the copy tags. So this is the walnut that, or this is the part of the walnut that we have segmented. You can go in the Z axis. Okay, now let us have a look at this data in Drishti. So this is the mask information that we have saved, and we'll directly look at the mask information using Drishti. So let me run Drishti. Let me turn that off. Let me run Drishti here. And let me drag and drop this pvl.nc file. Now we don't see anything here because our mask value has value 1. So when I move my transfer function, to this point, you will see this walnut here. Now this is what we are looking at, is the mask information here, and this is really hard to pick. So what we do is we will load two volumes. First is the original volume and second is the mask volume. Now press F2. Okay, so this is the walnut. Let me press C, and this is the area that we had segmented. Let us use mix tag. So mix tag, and this is the tag. That was the region that we had segmented. Now this color you are getting from the tag color. So this is the color that is used to tag the walnut. So you can change that color to whatever color that you want. Change the opacity, and this is the tagged volume. What we can also do is, let me just kill that, is now instead of looking at the volume and mask in this way, we can actually just save that portion from the original raw file. So we can extract the tag region, and we are going to extract tag region 1. We are not going to apply any smoothing or any dilation or erosion, so that's why the spread is 0. And then we are going to extract the image data, save the image data as say core. Done. So this is the data that is saved, core, and now let's load that into Drishti. So I'll drag and drop this core.pwl.nc here, and this is the region that we had tagged. So we have extracted walnut from the original data, and then you can use this to generate mesh and whatever you want to do further processing, or you want to get the volume. So in that case you can just do get volume, and it will give you the volume of this core, and so on. So click no. What you can also do is say extract region, again going through the same process. We don't apply any smoothing or erosion, and instead of image data we will save tags data. Okay, now this tag value 1 will be saved as 127, just so that it becomes easy to visualize in Drishti. So save that. Say let me save it as core tag. Okay, let me run Drishti again, and then drag and drop this core tag here. Now this is the tags volume, actual tags volume, and if you look at the histogram, you will just get a single peak here. This is the single peak that you get because we have saved our tag information as 127. So this is a way in which you can extract the tagged data from either your volume data or just the tags information.